appreciated that. We're going to go to our next presentation by Judy out of Estuary Escapes, and Judy was a program scientist with the CHNEP for many years, so happy to have you, Judy. Take it away.
Can you hear me now?
We can.
All right. Hello, everyone. Thanks for being out there. The purpose of our lightning talk is a little bit different than these other ones in the session. It's a little holistic to tie the pieces together. We'd like to encourage all of us to incorporate climate change responses into our water quality restoration projects, as well as our water quality monitoring and planning and regulations. We'll be moving through the slides fast. And on the last slide is a link to Dr. Keller's website where this presentation and references and other documents will be available. Next slide, please. So Charlotte Harbor has been experiencing a bloom in algae blooms since about 2012. And these blooms have been lasting longer and occurring more frequently over wider spaces. You'll be hearing more about these filamentous algae blooms tomorrow with Dave Lewitt's presentation and Betty Stogler's. And these blooms have been observed by FWC fisheries biologists, Charlotte Harbor Aquatic Preserve, seagrass monitors, and the seabird agents as well. And interesting enough, 2012 was also the year that the Indian River experienced its crash and burn based on filamentous algae blooms and declines in fisheries and seagrasses. So many of us have been trained to think of the primary causes of algae blooms and water quality declines as being from excess nutrients, and that those excess nutrients are coming from human activities like inadequate wastewater treatment and stormwater management. But there's new studies that indicate just how strong of an influence climate change is having in fueling these harmful algae blooms. In 2014, NOAA published a study that showed we could expect more frequent algae blooms around the country as we experience the results of climate change, and that's bearing fruit here in Charlotte Harbor as well. We know the list of solutions, sort of: comprehensive water quality monitoring and reporting, managing nutrients below state standards, revising our stormwater and wastewater treatment regulations and designs, and mitigating climate change as well. And before I forget, there's a really good source of comparable water temperature information is the 20-year fixed station 50-site sunrise monitoring that occurs throughout the aquatic preserves under the DEP Charlotte Harbor Estuary Volunteer Water Quality Monitoring Network, so that synoptic time sampling allows us to see the changes in temperature better. As far as managing nutrients below standards, we have to be careful not to be complacent about holding the line. Indeed, if we hold the line in our nutrient inputs, that doesn't help compensate for increasing population and imperviousness, as well as warming temperatures, intensifying rainstorms and hurricanes, and drought in between, as well as increasing use of reused water. So if we want to improve and restore estuaries, we need to actually have stricter guidelines. And the interesting thing about the water regulations, the stormwater design, is Florida recently passed a bill that requires us to update those stormwater designs by 2021. And that will give us all a good chance to have input to make sure that those new designs aren't inundated more frequently than they're designed for, so that that first flush of nutrients and sediment is retained in the ponds more frequently. And then the rest of this presentation is going to be a lot about mitigating climate change. Next slide, please. So climate change is important for us to adapt to, but in order to reduce our water quality declines and our algae blooms, mitigation is just essential. As a reminder for many of us who aren't used to the climate change lingo, adaptation is us getting used to the climate change impacts like sea level rise and increasing hurricanes, and it's our process of adjusting our infrastructure to accommodate that. Mitigation, on the other hand, is our actual active intervention into reducing these heat trapping emissions and removing carbon from the atmosphere. This is the only way we're going to be able to curtail climate change before it gets to be unmanageable and a point of no return. So the combination of adaptive mitigation is a best approach for communities in order to be able to have resiliency in the short term and yet have a long time mitigation, have a long time hope of sustaining as well. Next slide, please. Next slide. Hello. Next slide, please. Hello? Okay, so our mitigation, nope, go back one, please. Our mitigation efforts have to be really large scale and really immediate. There's agreement among international scientists about the extent of climate change and the rate of climate change. There's a long list of reports here and on Dr. Keller's website. Some of the important ones started with the IPCC report on global warming in 2018 up through the UN emissions gap report in 2019. But the gist of all these reports is that it's necessary for us to aim to reduce our emissions globally by 8% a year over the next 10 years. And that's really a challenge. So we have to have a combination of mitigation and strategies, which includes enhancing conservation. And it also includes replacing fossil fuels with energy sources that have zero emissions, such as solar, wind, nuclear, hydro, and geothermal. And then we have to actively mitigate carbon, sequester carbon out of the atmosphere through reforestation on a large scale and soil management practices for large scale agriculture. Next slide, please. So mitigation is our fastest route to achieving, leveraging is our fastest route to achieving this mitigation on such a dramatic scale. If our goal is to reduce greenhouse gases by 80% in 10 years, that means we all have to work together in a cooperative manner. So global cooperation includes governments and their agencies under them on a national level, as well as businesses and nonprofits, individuals, and universities. So a combination of expertise. And we know this is a huge challenge, but this leveraging is important to be accomplished through interdisciplinary programs like combining policy science, economics, and regulations, as well as different geographic jurisdictions like national, state, and local governments. Next slide, please. So from a federal government leverage in the US, we really need to get back into our climate change action. I don't know if you understand that together with China, the US contributes 40% of the global emissions. So that gives us a lot of responsibility to contributing to the reductions. Interestingly enough, it was the US that initiated the Paris Climate Agreement with China in 2016. It has been signed by 186 countries, but when we withdrew from the climate agreement in 2019, we kind of pulled the rug out from under it. So it's time for us to get back into that. Within our national government, we need some legislation that puts a price on carbon and returns those net revenues back into households to encourage conservation. And there was a bill introduced in January a year ago in the House that creates a carbon dividend trust fund. And the idea is to encourage market-driven innovation for clean energy technologies, but that currently is sitting in committees. And okay, 1 minute. So interesting enough, the pandemic recovery plans could incorporate clean energy initiatives distributed geographically and provide lots of economic incentives and job opportunities. Next slide. I'm going to summarize this. State governments regulate utilities, and electrical power is one of the produces a third of our emissions. So we need to revise our state utility regulations to foster conservation and clean energy. especially eliminating barriers to rooftop solar and community solar so that that energy can go back into the grid. Next slide, please. Local government strategies are important for water quality and also for sequestering carbon through our building and landscaping plans. And the 2021 comp plans have to be updated to address climate change, hopefully including mitigation with the adaptation, as well as stormwater infrastructure and improving stormwater treatment and revising codes, and creating energy efficient public transportation. Okay, last slide. All right, we're wrapping it up. We heard that excess nutrients with climate change are affecting water quality. We need to mitigate. We need to revise our stormwater regs, and we need active mitigation to be able to accomplish that. So as resource managers, we are responsible for guarding and restoring water quality and habitats. So it's time for us to take an active role in incorporating responses to climate change in those plans and restoration projects. Next slide has the links. There's the links to how to get more information, and thank you so much for your time and listening fast. Questions?
Thanks, Judy. Now, if all of you out there can go to menti.com and enter your questions now, it should start to display here in just a second. Great, thanks. Judy, feel free to answer them as they come in.
All right. I see this excellent comment. It must be from my co-author. All right. Thank you, everybody. Have there been publications specific to Charlotte Harbor that show water temperature increases and biological response to climate change? One of the papers that Dr. Keller did recently for Charlotte County did look at climate change temperatures, looked at temperature increases in Charlotte Harbor, and we looked at that volunteer estuary water monitoring data that I was talking about, and you could see in Charlotte County the temperature is definitely increasing. In terms of the biological responses, that's a really good question. Someone who does research over my head should probably give us a summary of how increasing temperatures shift biological processes and shift species dynamics, not only in between algae and seagrasses as they shade the light, but also between the species of algae and the species of seagrasses that are present. What are some of the state bills we can look for? Sorry, there's two, one that's in the House right now for the carbon tax, and the other one that is required by January 21 to redo the state stormwater designs, which goes back to the presentation earlier this morning, keeping in mind that we are seeing not only more flushing out of the existing stormwater designs, but also the nearshore legacy sediments, as somebody said this morning, with the detritus during king tides. City of Punta Gorda has a comp plan. Do other local governments have these? They're supposed to have their comp plans on a county level, and the state is required that those comp plans be updated by next year to incorporate climate change considerations, mostly resiliency. So we're asking that mitigation and sequestering options, carbon sequestering options also be included in those. Punta Gorda's is pretty good. We do, with all these, sorry, my scientist speaking, but it's time to get science back into some of our policy making processes, and there's a lot of elections coming up in the future, so it would be helpful for us who are scientists and understand the impact of these to make sure that we convey that message through our voting. I don't know the percentage of U.S. pollution of emissions contributed by China and us. I'm sure that's available on Dr. Keller's website. Examples of good storm water management to look at. Well, I tell you, I've been doing the stormwater management thing for 40 years, and we need some new designs that help us hold the water longer, because that first flush of sediments carries a lot of nutrients. And I think that's it. Thank you, guys.
Thank you very much.